Hey guys, our topic is on volume, molar volume, and standard conditions. To start it off, let's define volume. Volume describes the amount of space an object takes up. In the context of gas, it describes the amount of space taken up by the given gas.
Molar volume is the volume of 1 mole of a gas under standard conditions. Before we continue with molar volume, we must first understand standard conditions.
Imagine measuring the volume of the same amount of gas in different environments, perhaps a desert or the top of an enormous mountain. The same amount of gas would have different volumes in these two environments. There would be no universal relation between its volume and mass.
The volume of a gas changes with temperature and pressure. With greater temperature or less pressure, a gas will expand, and with less temperature or greater pressure, a gas will contract. Therefore, it is necessary to have a standardized environment in which gaseous volume can be measured and compared with one another, hence, standard conditions.
The standard condition is in a standardized environment in which the temperature is 273 Kelvin and the pressure is 101.325 kilopascals. We would call this the standardized temperature and pressure, also known as STP. 101.325 kilopascals is 1 atmospheric pressure, which is the pressure at sea level on Earth's surface. 273 Kelvin is 0 degrees Celsius, which is the freezing point of water.
The equation to derive molar volume is V equals nRT over P, where P equals pressure in pascals, V equals volume, N equals number of moles, R is the universal gas constant, which is 8.31, and T is the temperature in Kelvin. Ensure that you're using Kelvin when working with gas laws. If we had used Celsius, then the standardized temperature would have been 0 degrees Celsius, and anything multiplied by 0 is just gonna be 0.
You may be wondering where this equation comes from. It's derived from the ideal gas law, PV equals nRT. By dividing the ideal gas equation by pressure on both sides, we can solve for the volume. This means that you can find the volume of any gas if you are given its molar amount, temperature, and pressure.
So let's find the molar volume of a gas under STP. We have the equation V equals nRT divided by P. 1 mole times our gas constant, 8.31 joules over Kelvin, times mole, times the standard temperature, which is 273, all of this divided by the pressure, which is 101.325 kPa. Moles cancel out with moles, Kelvin cancels out with Kelvin. Now we are left with joules over kPa. So how do we get the unit for volume, which is liters? After all the canceling, we will have joules and kilopascals left. So joules is actually equals to newtons times meter, and pascal is actually equals to newtons divided by meter squared. So we will have joules over kilopascals left, and joules is actually equals to N times M divided by kilopascal, which is 1000 N divided by meter squared. And then we will multiply that reciprocally because this is a division of a fraction. We will have N times M times M squared on top and switch up, so 1000 N at the bottom. The N cancels out, and then meter times meter squared will be equals meters cubed, and at the bottom will be 1000, which is actually equals to decimeters cubed, which is actually equals to liters.
Alright, now we've shown you that the volume of 1 mole of an ideal gas under STP is 22.4 liters.
However, gases are complicated because there are many external factors affecting its behavior. Ideal gases do not actually exist in the real world. To solve this problem, chemists came up with an ideal gas equation so that we can better understand the behavior of these gases while ignoring those external factors. Because we are ignoring these external factors, not all the molar volumes of gases will add up to 22.4 liters. Even though 22.4 liters is not to the utmost accuracy, we can still use it because in real life, the molar volume of the gases are close to 22.4 liters.
Similarly, The laws of Boyle's law, Charles' law, and Avogadro's law will not always work in real life with all the real life gases because all real life gases do not always work ideally.
Let's do a practice problem using the equation for molar volume. Ethylene gas reacts with water vapor to produce ethanol gas. Here's the balanced equation. What mass of ethanol will be produced if an excess of water comes in contact with 2 liters of ethylene? First, convert 2 liters of C2H4 to moles. We know that 1 mole of C2H4 will have a volume of 22.4 liters. The liters cancel out and we are left with 0.089286 moles of C2H4. From this balanced equation, we know that for every 1 mole of C2H4, 1 mole of C2H5OH will be produced. Now you have to find the molar mass of C2H5OH, which is 46.08 grams. Moles cancel out and you get 4.1143 grams. Remember to keep track of your sig figs, which in this case your final answer will be up to 3 sig figs. Your final answer is 4.11 grams.
Alright, now to recap. The volume of 1 mole of any gas under standard temperature and pressure will be 22.4 liters. Standard conditions are when the pressure is at 101.325 kilopascal and the temperature is at 273 kelvins.